Next, let's move on to try some examples of differentiation. So if you were to differentiate 4 sine x, what we can do as we start out, you know that 4 is actually a scalar multiple of sine x. We could put it outside. So it will be 4 d over dx sine x. Okay, so 4 remains as 4. And then we carry on to differentiate sine x, which gives us cos x. So that will be the answer for the first question, which is rather simple. It's just a direct application of the first differential. Now the next one, y equals to 3x squared multiplied by tangent 5x. You realize that for this particular question, to find dy dx, this expression on the right hand side is divided into two parts. You have 3x squared and you have tangent 5x, and they are being multiplied by each other. So in order to find your dy dx, you will have to recall one of the 5 rules that you have learned about differentiation earlier on in the chapter. What comes to mind will actually be the product rule. So product rule states that you have the first part, you leave your 3x squared as it is, differentiate tangent 5x. So if you were to differentiate tangent 5x, you will have to consider this, right? Okay, what is f prime x? F prime x is actually the differential of 5x, which gives you 5. So 5 and then secant square x. Okay, so this is the first portion. And the second portion of the product rule plus, so we leave tangent 5x as it is. And we continue to differentiate 3x squared, which gives you 6x. And from here, we could simplify. So we have 15x squared secant square x plus 6x tangent 5x. Okay, so this is the answer for the second portion. Okay, for the third one, fx equals to this entire portion over here. You realize that it's a fraction, so you could consider using the quotient rule. It's important for us to decide what rule we want to deploy before we carry on our differentiation, so that we are clear about our steps. So when we differentiate, instead of fx, we consider f prime x. So the quotient rule states that we have to have our v, right? And then we differentiate u. We differentiate u means we want to differentiate our sine for x. We bring out the 4 as we differentiate for x. The cos for x minus, we keep this constant. And now we differentiate cos pi by 2 minus 2x. Let's differentiate this to minus 2x first. When we differentiate, we get minus 2. And when we differentiate this portion, minus sine this whole thing, right? Minus sine pi by 2 minus 2x. Okay, so we have the whole string of expression, and don't forget we have to divide by v squared. And what is v squared? It will be cos squared pi by 2 minus 2x. Okay? Yeah, so I hope that I'm clear here. And next we move on to simplify what we have. So as we simplify, we will end up with bring out the 4 first. Cos 4x cos pi by 2 minus 2x minus, 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 so I will end up with a negative in the end. Negative 2 sine 4x sine pi by 2 minus 2x, okay, over the denominator, which does not change, cos squared pi by 2 minus 2 pi, sorry, mistake, minus 2x. Okay, so that will be our answer. You realize that at this point in time you cannot simplify it anymore. Now next we'll take a look at the example that says to differentiate 5 times sine cube 2x. This actually means that it is differentiating 5 times sine 2x and the whole thing is being cubed, right? So what happens in this case is we could actually bring out the 5 times d over dx. Excuse me. Sine 2x cubed. So this leaves us to differentiate this portion here. So when we differentiate this portion here, we leave the 5 as it is first, and we differentiate this using our chain rule. Yep. So if this is one single letter x cubed, it will be 3x squared, right? But because there is a coefficient of x, we have to move on to differentiate the x, the 2x in there. So what happens is that we bring down the 3, we have sine 2x squared, and thereafter don't forget to differentiate whatever is inside here, the so-called fx. So it will be 2 cos 2x. Okay. So simplifying everything, 5 times 3 times 2, we get 30 sine square 2x. I actually bring my square in times cos 2x. So that will be my answer. Hope you are able to follow so far. Yeah. Okay, next one. This is really long. I will save it for the next video.